This is where probability of combined events starts. Probability of combined events is where probability starts getting a little tricky. For instance, question ये है कि what is the probability that two fair dice are rolled? What is the probability that both dice show the same number? So for instance, जब आप लूडो खेल रहे हो, मोनोपोली खेल रहे हो, any game that you're playing, 1-1, 2-2, 3-3, 3 on the first die, 3 on the second die. What is the chance that this is going to happen? How many possible options do you have? Remember, we studied probability of an event happening. What's the event over here? Getting a 1, 1, 2, 2, 3, 3, all the way up till 6 or 6 is number of favorable outcomes. Number of favorable outcomes over total number of outcomes. Okay? How do you know how many favorable outcomes do you have? Well, that's pretty simple. We have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So that's going to be 6. Now, how many total outcomes do you have? This is where students get stuck. So for that particular reason, we're going to learn something called possibility diagram. Possibility diagram. That is part of the course that is going to help you identify what we are supposed to do when we're stuck with such a question and how to get out of such a problem. Now the answer was 6 by 36. We're going to come back to it after a little while. The second question is number on the first die is greater than the number on the second die. Now it's even more detailed and even more tricky. They're asking you what is the chance of getting the first number should be greater than the second number that you get. So for instance, if you roll them one by one, if you roll die 1 and you get 2, this is the first number, it should be greater than the number that you get on the second die, so it should be 2, 1. Similarly, on another turn, for instance, if you roll 3, so on the first die you should get a number which is on the second die, sorry, you should get a number which is smaller than the first die. So it should either be 1 or it should either be 2. Now what is the chance of rolling a first die and getting a 4? Now the first die number, remember the number on the first die should be greater than, that's what the question requires. You're going to say 4, 3, 4, 2. I mean, that's going all over the place. You're going to do that for 2, for 3, for 4. That's going to waste a lot of time. The answer is 15 by 36. But how did we end up with that? Once again, we are going to learn possibility diagram. With that, it's going to be really easy and real quick. To avoid all confusion, whenever we have such a question that has 2 components. What 2 components? One die after another. Okay? One coin toss after another coin toss. That's 2 components. We will make a possibility diagram. Now this is really easy. अब आप देखो first diagram क्या values यहाँ लिख लोगे? First die की 1, 2, 3, 4, 5, 6. I mean that are all the possible options on a die. Second die की अब possible options यहाँ लिख लोगे 1, 2, 3, 4, 5, 6. Now fill out all the table that forms beneath. You might be wondering that this is going to take a lot of time as well, but I don't think so. This is what you need to do. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, so on and so forth. Before you know it, in under a minute you will be done with this table. Once you are done with the table, now the question said both dice show the same number. Remember? Now that's pretty easy. 1, 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. 6 out of a total of how many options do we have? You just simply count them up or multiply this number which is 6 by this number which is 6, 36. Now the second question says the first die, the number on the first die should be greater than the number on the second die. This is the first die. You labeled it yourself. You can even label this as the first die, but if you labeled this the first die, number on the first die should be greater than the number on the second die. So you have all those options down here. 1, 1, 3, 1, 4, 1, 5, 1, going all the way up till here. So all these options marked in orange are all those numbers which, all those cases, all those possibilities where the number on the first die is greater than the number on the second die. As simple as that. Right? If you count them up, how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if you remember we had the answer 15 up there. Wait, hold on. Here we go. 15 by 36. Let's go back to another question. Similar question. Two-fair die roll once again. Find the probability that the sum of the numbers shown on the die is 5. Now whenever you have sum, now you might be wondering, alright, it's once again 2. So this rule applies. You're supposed to make a possibility diagram because it has two components, but now they're saying sum. No problem. This is where you're simply going to put a plus sign. This was blank. In such a case, you're going to put a plus sign. So instead of writing 1, 1, you're going to take the sum of these two and write 2. So the sum of 1 and 2 is going to be 3. Let me hold on. Circle that properly. 1 and 2 is going to be 3. The sum of 1 and 3 is going to be 4. So you are basically supposed to move sideways. Apologies for this. You can either move horizontally first or vertically first. The sum of 1 and 1 is 2. The sum of 1 and 2 is 3. The sum of 1 and 3 is 4. So on and so forth. So before you know it, you will have filled the entire table. Once you fill the entire table, now the question said, find the probability that the sum of the numbers shown on dice is 5. All those highlighted in orange are your answers. How many are they? How many numbers are highlighted in orange? 4. So the answer is 4 by 36. Find the probability that the sum on the numbers shown on the diagram is even. Now all those numbers which are marked in green are even. So count up all the numbers which are marked in green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. 18 by 36. 36 is the total number of outcomes. Going all the way from here, down here, and then back here. This goes in the denominator, the number that you require. I mean, sometimes it's even, sometimes it's sum of 5. That goes in the numerator, and that becomes your answer. The second most important and tricky concept is, no, I won't call it tricky, I'll just call it important. 3 fair coins are tossed. Whenever you have such a question where instead of 2, you have 3 components, find the probability that there are 2 heads and 1 tail. So for instance, imagine this guy is tossing a coin. So once he tosses a coin, he catches it and he looks at it and he records it's a heads, right? So he writes it down over here, heads. He does this process again, he catches it and he notes it down, it's a heads again. He does this process again, it's a heads again. 3 heads, that's one possibility. Now he does that experiment again. How many times? Until he's gotten all the possible options, all the possibilities. He gets 2 heads, and on the third time he gets a tail. He gets a heads the first time, a tail the second time, and a heads the third time. How many possible options are there going to be? Now this is where it gets tricky. That's why I labeled it tricky at the start, but then I thought against it. Whenever you have 3 coins or 3 things, note this down. To avoid confusion whether a question has 3 components, we will make a tree diagram. Now the answer for the first part was 3, and the answer for the second part was 7. I mean, you can always go back and try to read it, or we'll try it over here. There are 2 heads and 1 tail. I haven't been able to come up with all the solutions. There would have been multiple other solutions. I, however, know 2 heads and 1 tail. 2 heads and 1 tail. This has 2 heads and 1 tail. This has 2 heads and 1 tail. There's another possibility that would have 2 heads and 1 tail because the answer says so. But how do we know there are how many options there are? I would, instead of going into the detail of this and wasting any more time, try to study this first. I will make a tree diagram starting over here. So basically you can try to understand the concept of tree diagram as a storyline. Just a movie के अंदर नीचे एक timeline चल रही होती है. तो आप whatever point in movie that you want to watch, you can simply hold that point and drag the cursor along the timeline and watch that movie at that particular time. So imagine this is where the movie starts. This is where you've decided to toss a coin. You toss the first coin, you get a heads. Your movie has almost gone around 30%. What happens in the second part of the movie? You toss another coin, you get a heads. And the third part of the movie, where you finish the movie, you toss the third coin, you get a heads. That is where the first or in that particular order, in those particular scenes, the movie has ended. Imagine there's another movie, or you start all over again. Imagine if you have the chance, you are the writer, so you're the screenwriter, you are choosing how the story goes. Imagine you've chosen that the uh, main hero or the character of the movie tosses a coin, gets a head, tosses the second coin, gets a tail, tosses the third coin, gets a head. Or you could have chosen this path. Gets a head in the second part, second toss of the coin, gets a tail in the third coin toss. So basically, it's moving in vertical columns. This is representing the first coin toss, this is representing the second coin toss, this is representing the third coin toss. Right? I'll move all of this now so we can go back and study the question. The question says, do you get two heads and one tail? So let's check all our possibilities. Two heads and one tail. Two heads and one tail. Because in this path you will see we came across a head, one tail and another head. What other scenario do we have for two heads and one tail? One tail and two heads. There is no other possible options. So how many possible options do we have over here? 1, 2 and 3. That is why this number had 3. Now how many total options do we have? We have, let me erase this number. We have 1, 2, 3, 4, 5, 6, 7 and 8. That is why we have 8 in the denominator. See now, when we're solving it with the help of a diagram, it becomes really, really easy. Now the question says there is at least one tail. One tail. At least का मतलब है कम से कम, so we can have solutions which have more than one tail. Here we go. We are going to look for and highlight all the possible options जहाँ पे एक ना एक tail हो. It has all three tails. This counts. Tail, tail, head. Well, it has at least one tail. Tail, head, tail. It has one tail. Tail, head, head. It has one tail. किधर है? Yes, right at the start. ठीक है. Or we can have head, tail. No, wait, hold on. Let me highlight that. We can have. We needed, remember, one tail. One tail. So it should have at least one tail in its path. Head, tail, tail. Or head, tail, head. Or head, head, tail. All of those possible options have, except for the one at the end. I'm going to mark that in red because that doesn't count. Head, head, head. This doesn't count. Because they're saying they should have at least one tail. So we have 1, 2, 3, 4, 5, 6, 7. 7 out of a total of 8. That is why this answer had 7 out of 8. See, so whenever we have two components that we're solving for, draw possibility diagram. Whenever we have three components we're solving for, draw a tree diagram. It makes your life very easy. I hope this tree diagram made sense. I'll make a tree diagram. Hold on for let's make a tree diagram for, although this might take a lot of time, but I'll try to. Let's make a tree diagram for rolling a die. Okay, rolling a die. What are the possible options of rolling a first die? This is the first roll of a die. So I can either get a 1, a 2, a 3, or 4, or a 5, or a 6. So I'm rolling 2 die. Second roll. Once I get 1 on the first die, I can get 1 on the second die. I can get 2 on the second die. I can get 3 on the second die. 4, 5, and 6. See, imagine all the possibilities that are going to form. Now this process is going to repeat for, look closely at the screen. Hold on. This is going to repeat for the second die, the third die, the fourth die, the fifth die, and then sixth die. So that's going to be tons of possibilities. That is why whenever we have two possible components, we make a possibility diagram. Whenever we have three, we make a tree diagram. It helps in basically mapping out all the possibilities and then easily being able to come up with solutions. Right? So I hope it made sense. This was tree diagram and a possibility diagram. The next video is going to include these two concepts, and in the process we're going to be solving some trickier questions. Khuda Hafiz and take care.